Welcome, ladies and gentlemen. We are progressing quite well. We talked about mean, median, mode, standard deviation. These are fundamental bases before you go to Six Sigma and implement this to have a robust system that is going to save your cost, make your organization sustainable, and ensures sustained success of an organization. Now, there are a lot of common concepts in Lean Six Sigma and ISO 9001 2015. In fact, ISO 9001 2015 demands, requires that an organization actually does undertake, analysis of data. And one of the principle of quality management system is evidence-based decision making. In 2008 version, the principle was factual approach to decision making, which in 2015 one standard has been renamed as evidence-based decision making. The whole idea is before you make a robust decision, you need to analyze data and evidence. Now, Six Sigma talks about that kind of data management system or data-driven system where you actually improve the system to get better results. And those evidences will come from analysis of data. I'll give you some practical examples how an organization can simply apply Lean and Six Sigma principles at least. There is a lot of mathematical considerations and mathematical calculations that is needed. However, every organization can appreciate the value of Lean and Six Sigma, that it is extremely beneficial for an organization. And certain principles can be very easily adopted by the management, and that will give them huge amount of cost savings and operational efficiencies and effectiveness. One such concept is seven wastes. When it started, it was seven wastes. Now, later on, one more waste was added. Now, simply waste is something for which the client is not interested to pay and client does not pay for it. Some of the wastes are necessary but does not add value. For example, transportation. You have to transport your goods, deliver to the customer. It is essential. It does not add value. Customer doesn't pay for this, but you have to incur this cost. So transportation is a cost which is non-value adding. But delay, for example, is avoidable. So waste sometime is avoidable. There is some non-value adding activity you have to do, even though you do not get paid for it. But certain activities, certain wastes can be prevented, which is not required for product and service realization process. The central focus of the lean management is reduction in wastage. Because if you reduce waste, you add value. The waste is a cost. So you have to reduce the cost. And it reduces the cycle time for production. For example, yesterday, one of the example I've given is how you can make coffee quicker than before. Earlier, it was taking 7 minutes. Now you can make it, say, in 3 minutes. When Xerox photocopying was initially introduced, and Xerox was a very pioneer, so Xerox has become synonymous with photocopying. Many people say Xeroxing. Actually, it's photocopying, but the name of Xerox became kind of synonymous with photocopying. I myself have done photocopying just to see it used to be a very huge machine, like an X-ray machine. You have got the plate, you have to put this, paper for copying, and then you apply the heat, and that heat transfer happens. You remove the excess ink. There will be tons of juice and waste that is piled up. It's so dirty, and then one page will come after, say, 2 minutes time. But it was wonderful to have a photocopy in 2 minutes time at that point of time. Now, in 2 minutes, you could possibly make 200 pages, print out on both sides. So there has been significant improvement in the processes. So you improvised the technology in the process. So time for Photocopying, which used to take for one page 2 minutes, now in 1 minute you can make 20, 30, 40, 50, 60 copies. So that kind of an improvement has taken place. So lean management is all about reducing the wastage and making it more faster. I'll talk about a little bit of history of lean, how the whole concept came. And you have to give great credit to Toyota. And Toyota production system is greatly founded on lean principles. And Kichiro Toyoda, who was one of the director and the owner of Toyota family, and he was a prime mover for the lean processes. And Taichi Ono, one of the engineer, was really instrumental in developing the whole concept when they visited Ford and they realized that Ford is such a huge, massive company, more than 10, 11 times bigger. Their turnover, their resources, their place and space and their technology. And Toyota did have nothing of that sort to compete with them, but still they have to be there in the business and grow as an organization worldwide. So they realized that what Ford can afford to do, Toyota cannot even imagine because of their sheer ability to mobilize funds and the space and stuff like that. So they have to be very innovative to reduce time for production and be flexible in terms of their activities and the processes. So the same space has to be utilized for multiple products, multiple models. So once you start multiple models, the changing of the dies are very important. So you have to have system in such a way that your wastage of time is reduced. Even the wastage from time from one type of die to another, die for one model to changing the die for another model must be controlled in such a way that the very quickly they can change the dies so that in the same production line you change the die, a new car can be produced in the same production line and you don't overproduce. So I'll talk about those things, what all Taichi Ono was introducing and the whole team. It's not only one person, but there was a team, but the prime mover and the driver was Taichi Ono. So these 8 wastes, you can use a mnemonics called TIMUDS. Now what is that? T for transportation. As I mentioned, transportation is a cost. I'll elaborate them more. Right now, let us first talk about those elements. So unnecessary transportation is a cost, or transportation is a cost. So avoid unnecessary transportation. Then I for inventory. If you have got a large inventory, then your money is blocked. I'll give an example of a company that I have audited in 2002. They had 7-8 months of inventory of steel and a huge amount of material was stockpiled, raw material plates. Now that amounts to almost 8 months of production stock. Few million Kuwaiti dinar multiplied by 3 will give you few million US dollars. Were always blocked in the form of raw material and the space, of course, where they're kept. And also they need preservation. They're exposed to the open sun and dirt and rain and all those kind of things. So you need to protect them. So space is blocked, money is blocked. You have to preserve them. There is another cost, and all those things add cost to the production process and the product. So excessive inventory is counterproductive and is a cost. Then comes movement, unnecessary movement of material or the products. Car production system is very well organized. Actually, if you have seen a car manufacturing facility, I've worked in a car manufacturing company, Hindustan Motors, and I have visited some of the finest automobile company in the world like Ford in Detroit. So it is exceptionally good layout they make to reduce unnecessary movement of material and the product during production process or even delivery. For example, the press shop where the material comes in, and then it goes to body shop, and through the conveyor, it goes to the paint shop where the body is cleaned of dirts and oil and grease and stuff like that, because painting is going to happen. And then after the painting is done, it comes to body trim assembly called BTA, where all the trims are fitted, seats, harness, steering, and all those components. And then finally, it comes to, car line, where you are going to fit the engine, gearbox, and all those mechanical components. And by the time it comes out of car line, the car is ready and you can really start. So you can see from a body which is like a shell, from there it's getting painted and all the components are fitted, and then finally it comes. So the movement of the goods are very, very optimized. So there is a sequential logical progression. So it moves with the least disruption. So movement is very important. I give an example. There was a company, I will not name this just for the purpose of confidentiality. In fact, the company is a steel mill. So they make stainless steel, the plates. So the production line, when it starts after the rolling process, again, it comes back to a place where solution handling is done. You know that solution handling is done for stainless steel. So they are heated at somewhere around 1000 degrees Celsius, and from there they're quenched in water. So that process is called solution annealing. This is done to avoid forming chromium carbides. So that's the metallurgy. Now, point I'm saying is, it is going in certain way, suddenly comes back to another place, and then again after solution handling goes back for inspection and cleaning, and finally it goes out to the customer in the loading area, and this goes. So the question is, why this pickling passivation plant is here? Ideally, that should have been there. So now it was a question, and many of the operation persons at that point of time did not have the answer why this was done. But then it was found is that there was a building at that point of time, an administrative building. So when the factory was set up, they didn't want to disturb this facility, which was used for the shop floor production and manager's office. So the pickling passivation plant was erected away. After a few years, that office was demolished. But to remove this plant from there to its right place would possibly disrupt the process for a while. So they allowed this to continue. So in the process, what did happen? They lost a lot of time and movement that went unnoticed, and the waste actually have piled up, which remain unnoticed because nobody really cared. Okay, from there it comes here and then it goes back. So what big difference it makes? But the transportation, handling, additional cost of movement and usage of crane and stuff like that, and the utilization of the space, these are all adding cost. So that can be avoided. So unnecessary movement is a cost. Next comes waiting. In T-moods, the W stands for waiting. Now, if you have to wait in the production process, that's a big problem. And it does happen a lot. It really does happen a lot. For example, construction company, they have got a timeline to erect and commission the project. If some structural components are not coming, the pressure vessel got delayed, or the skid mounting package got delayed, it really, really happens. We have seen. Sometimes pipes are coming late. And because of that, the whole crew is waiting. Imagine per day in a company where 1,000 people are working, and 3 days they're just waiting and idling because the material did not reach, is a colossal waste. So waiting is a big cost. This waiting can happen in many places. In production line, you don't have the raw material, so you are waiting. The example that I've given in the first case, while I was talking about the inventory, this company was huge and they're a very rich company. They took the risk of over inventory to avoid any waiting time for material to produce. Because for them, they have to make a cost benefit trade-off. If you keep the inventory, steel if there's a disruption, because of the geopolitical situation, there are a lot of disruptions. Potential for delay in supplying the material was very much there. So they wanted to keep the stock so that their production does not suffer. Now, the same company, when I am auditing now, their stock is less than 30 days. In most cases, 15 days. Now, a fantastic gain by the organization's management. 7-8 months inventory now is less than 1 month. So this money is now circulating and being reused and reused much more times instead of keeping the money blocked. The space that were being occupied by those plates and the raw material is now free. So they came up with a whole new production shed. Just imagine they've got so much of space, which is very, very expensive. At the same time, they reduced the stock inventory. Whole new shade was made in that place. So what can be better than this situation? So waiting at times is big consideration. So now, what is their strategy? They've aligned long-term, the mutually beneficial supplier relationship, and supplier relationship management is one of the principle of quality management. So they have really taken it seriously. They've entered into contract with several leading suppliers of steel in the world, and they have given, based on their projection, that, oh, well, we need quarterly 10,000 metric ton, and you provide 3,000 metric ton this month, another company providing 3,000 metric ton. So on a 3-month cycle, everyone is providing 3,000, 4,000 metric ton of plates. So they have adopted just in time. So you have got the right material on right time without excess inventory, and huge amount of cash got liberated and the space got liberated, and that's how you can apply those lean principles. So I don't see, when I'm going and I'm looking at those aspects while auditing, and I find it's almost zero. There is no delay in production due to shortage of material and waiting. Next is overproduction. Overproduction is waste. It's a very strange concept. Some people can say how overproduction can be waste. In Hindustan Motors, when I was working as a young engineer, we were manufacturing almost 100 cars a day, 100 ambassador cars a day. If it is less than 100, you have a big problem from the top management. So the president's information team is to be breathing behind our neck. How many cars have you released now? Last 1 hour, how many cars got released? And if there is a delay in the production, then, or there's a less number of production in the last 1 hour, then the production manager and manufacturing people will profusely sweat. I was in quality assurance department, but yes, I could see the heat for achieving the production target. I'm not saying you should go slow and production is not important. What I'm saying, overproduction is counterproductive and a waste. I'm going to explain how it is. For example, 100 cars we are manufacturing, and there was a demand as well. It's not that there was no demand. But strangely, we used to find hundreds of cars are now parked on the roadside within the factory. What was happening? All those cars are finished product inventory. Each car those days, I'm talking about 86, one car was 94 lakhs in Indian rupees, which was a big money. At that point of time, we were getting, say, 2,000 rupees per month salary, and just imagine 1 lakh was a big amount of money. I'm just giving the comparison for you to visualize what was the cost and affordability of a car by an average Indian. I was an engineer. It was a decent job to get 2,000 rupees as a beginner, but it was 1 lakh. And diesel car was, I think, 1,05,000 at that point of time. Now, hundreds of cars, a lying means hundreds of cars into 1 lakh on an average. This many crores are now stock, inventory, finished product inventory. So now your car, which is ready for sale, is lying idle with full amount of money invested for material, production and spare parts and all components. There are 90% items are bought out. All those items are fitted, but the car is lying there. So if you produce more than the requirement, that will be stock now. Now there will be annual depreciation. So now the sales guys in many companies are under pressure because you have got so many materials lying there, material got blocked, money got blocked. Now go and sell and sell, and it's okay. Go give some discount now. Give 5% discount, 10% discount. Now discount is what? You are cutting your profitability. Now sometimes you reduce the price to an extent that you make no profit. And mind it, for that period, those finished products were lying in your custody without going to the customer. You have incurred loss because there's a cost of goods. If the company is borrowing funds, there's a cost like interest, at least 10%, almost 9 to 10% interest is applicable in any bank. You are going to pay 10% or 9% or 11% interest to bank. So there's a cost to the fund, and that is lying idle, blocked. Therefore, overproduction is counterproductive. Now, Henry Ford wanted mass production. And truly at that point of time, that was a great idea. Because you produce more, people are waiting for a car, so more you produce, the time for someone giving an order to get it will be reduced. So people are really hungry and thirsty for a car. So it's a pride at that point of time to get a car. So Henry Ford actually introduced conveyor system in the production line, and that really made production very, very fast and swift. So that was a breakthrough in production technology to introduce a conveyor system. Toyota, on the other hand, after visiting Taichi Ono around 50s, when they visited, they found that they cannot compete in this process with Ford because they don't have so much of space and so much of money to block. So they realized that we have to be smarter. And that's where sometimes the necessity is the mother of all inventions, we call. So they came back and they realized that we have got one production line. In that only, we have to make these cars. So what way we can do? Brainstorm. And brainstorming gave fantastic ideas. That, well, we have got one production line, say for Toyota Camry. Great. We have got 100 orders. Say, for example, 100 orders for Camry Black this month. And 100, say, Camry White. And 100 Camry Beige color. And 100 Camry Silver Gray. So these 400 cars orders you have. So you exactly make 400 black, white, beige, steel gray, silver gray. And you are actually producing to meet the demand of the customer. You have got exactly demand for 400 cars now. So you are actually pulling, as if you are pulling and supplying the product based on the demand. So you are not overproducing. So your cars will not be lying in the showroom. They will go from the factory to the showroom, just clean it, go to the customer. So there is no inventory. This material are moving actually. You can see the material movement. Cars are produced, shipped, came to the dealer, went to the customer. And everybody is happy in the process. Now just imagine you have got 100 cars black produced, but there is no demand for this 100 black. But somebody ordered white, they're still waiting. So you have got excess number of some product which is not in demand, or others which are in demand is not produced. So customer needs something which they are not getting, and the company produced something which are not being sold. So you must come into a situation where you are actually pulling and supplying. So it's like a pull system, they call it. Rather than push system, you adopt pull system. So produce as many as you need based on customer orders. So from global network of dealers, they will get orders and they will make production. So next month, these many cars will be made. Now, They will change the color booth also at that point of time. After 100 cars are manufactured, then they will change the paint booth also. After that, maybe Toyota Land Cruiser will start. So the same, production line, you are changing the dies and the jigs and the fixtures. And now, during the production of Camry ends, one side it goes. So already they start removing those jigs and fixtures, replacing quickly with those needed for Land Cruiser, for example. So once 400 Camry is done, Land Cruiser automatically started in the same line. So those jigs and fixtures are kept in such a way, then they will be required again for the next batch. They'll be immediately brought back. So Land Cruisers, jigs and fixtures will be removed and replaced with, say, Corolla. That's how they are changing the dies and economizing the same production line, and all cars are produced under the same shade, and they are now very cash rich. Toyota is one of the most cash rich company in the world today. Whatever they sell is money is there with them, because they are actually supplying the demanded product. So there is no finished goods inventory that is unsold. So this is a fantastic situation where your sales and cash flow is so well balanced, and that gives you so much of liberty to invest and expand your business. So overproduction is really counterproductive, because that blocks your money and finished goods, and you are under pressure to sell even at the cost of losing your profitability. You'll be forced to do that. So overproduction is another, the waste. Overprocessing is also another cost and waste. For example, I have seen many people are grinding the welded joints, they're grinding. There is no need for doing such kind of things. Weld will have its natural appearance. So there will be some irregularities and some finish, which is just fine. So that's acceptable, unless of course there is some defect. You have to remove those defects and grind and repair, and all those things are fine. But you don't have to make it shine like a machine product, and it adds no value other than cost. So over processing or incorrect processing of goods are going to add to cost. So this also is another waste that you have to avoid. So we talked about transportation, inventory, movement. Then we talked about overproduction and over processing. And then comes defect. Defect is the most serious of all, because the product that you have produced is supposed to go to the customer, and now this is rejected. It's defective. I was involved in inspection and production at time of paper machineries. Paper machineries are huge. It starts from head box, then it goes to fourdrinier and the suction press roll, the series of rolls and the dryer and calendar. Finally it goes. Now the castings that we are making are huge. Say imagine a suction press roll inside component is, say, a 5 or 6 meter long or 10 meter long one casting. One casting, very complex shape of casting, almost 8 to 10 meter long depending on the span width of the machine, and one casting. So we are making in a place called Durgapur in India. Now, what was happening after, because of the climatic condition, technology available those days, once you have completed it and start half of the machining, you find a big blowhole. Or there is some problem with the casting, the whole casting is rejected. So if you make 3 or 4 castings, you might get one which is acceptable finally. And these are huge machining, because you can imagine the precision needed. So paper machinery is a very heavy and precision engineering. So now If you find a rejection or defect at the final stage, the entire cost of costing, material cost, energy, time, transport, everything is wasted. A finished product which could have been valuable to the customer is now zero. So this will burden the other acceptable products. During late 80s and 90s, the casting was a real big problem because chemical compositions were balanced based on experience of the people and some calculation, and sometime after the casting is done you find the chemistry is not acceptable or something like that, or some cracks or some defects. Technology was not advanced at that time to detect the chemistry. When the spectroanalyzer was introduced, fantastic opportunity came. In the molten state, you can take a sample and check the chemistry instantly in matter of minutes, and then you can balance, and then final product will never be rejected for chemical composition. So defect, which is a colossal waste, has to be prevented by all means, because defective product adds to the cost of the acceptable products. And something which was valuable to be sold has got zero value now. Even now you have to recycle it. You have to send it back to somewhere for recycling. So recycling also involves another energy consumption, again, rework, repair, all those things. So almost it's like an iceberg. There's so much of hidden cost in a defect. So you have to be very, very careful that your finished product does not get rejected. So quality planning became a very important part of product realization. And in ISO 9001 2015, the clause number 8.5, when product realization starts, and in clause number 8.1, they talk about planning for product realization. Clause number 8.1 talks about you must have a proper plan, product realization plan, project realization plan, how you are going to produce it from the beginning till the end, how inspections and verifications will be done at right stages and in between the stages, so that there is no rejection at the final stage, which will be colossal wastage. Therefore, you have to make sure you have got a proper plan to make sure the product is realized or services are offered without flaws and defects. So that is the D. And S is skill, unused employee creativity. Just imagine if the team of Toyota did not visit Ford at that point of time, they would not have known how massive and what are the processes Ford was adopting and what was working fine for them. And that appreciation that those things which are working in Ford will not work in Toyota because of their limited resources, capacity, space, and also financial resources. At that point of time, the size of Ford was 10 times or 11 times bigger than Toyota. Now, Toyota did not stop. Possibly that limitation became an advantage for them to become more creative, and the team led by Kichiro Toyoda and Taichi Ono was doing fantastic job to be innovative. They realized, well, we can have a process by which we can reduce this wastage. We can possibly start production of different models in the same production line, one after the other. Once one production is complete, take another production immediately, change the dies and change the jigs and fixtures, and start production of a new product or a different model. So it is said that untrained people are almost 30% less productive. So just imagine in an organization you are living with less productive people, and every day you are losing 30% of their output. Otherwise, they could have contributed so much better. And what is a colossal waste that is hidden? A defect you can see, but the talent that you are losing and untapped and unutilized is not seen. These are hidden costs in an organization. So develop the talent. In EFQM business excellence model, they call it succeeding through the talent of people. In ISO 9001 2015 clause number 7.2, we say this is competence. Even in occupational health and safety management system standard, there is a requirement of engaging the people and their participation and consultation to develop a better and safer organization. So engagement of people principle is one of the principle in ISO 9001 2015 standard as well, which is addressed in 9000 2015. So skill, unused employee creativity is a colossal wastage that you have to be mindful of. So I have covered these 8 wastes, which are you can use mnemonics to remember: team woods, transportation, inventory, movement. Then W stands for waiting time, and then you have got overproduction, overprocessing, and the defects, and the last is skill. I hope the discussion we had was interesting and give you some insight to think slightly differently. And trust me, a very important aspect of any organization manage is reducing the wastage so that you become more lean. Thank you so much. I'm going to talk to you on another topics, which is 5S. And this is going to be equally interesting and important for you. Thank you.